So number 4 says, given the chart from page 263, predict a molecule's shape and its polarity. So back on objective 3, we looked at what the Lewis structures look like for water. And water, remember, has got hydrogen single bonded to an oxygen. I'm sorry, two hydrogens single bond to the oxygen. Whereas carbon dioxide has the carbon in the center and the two oxygen are double bonded. The oxygen each have two lone pair and the carbon has no lone pair. So for the water, when I look at that, it's got two bonding pair, or what I like to think of as two bonding sites, two atoms bonded to it, and two lone pair on the center atom. It's only the center atom that matters. So that makes water a bent molecule. The two lone pair crowd the two bonding atoms. I'm still writing linear. It's bent or V-shaped. Whereas the CO2 around the center atom, there's just two bonding sites or two bonding pair. Even though they're double bonds, we consider them just one bonding site, just one atom bonded on each side for a total of two. And there's no lone pair. So since there's no lone pair to crowd those two oxygen, this one is going to be linear. Now the other question is, what does that do to the polarity of the molecule? Well, both these molecules have polar bonds because they've got two different atoms being bonded together. And because of that, one atom's going to be more electronegative or pull on the electrons more strongly. And in the case of water, oxygen pulls the electrons closer to it. This shared pair get pulled in this direction. So oxygen becomes partially negative, whereas the hydrogens end up with a slight positive charge. Over on the carbon dioxide, oxygen again pulls the electrons, all four of them in this case, toward it, making each of these oxygens negative, and the carbon ends up with a positive charge. But what's different about these two molecules is oxygen has, or the water has, a definite negative end with the oxygen and a positive end with the hydrogen. And that makes it a polar molecule. Polar meaning two different ends, a positive end and a negative end. But the carbon dioxide has two negative ends and a positive center, so that's not polar. That means the charge is equally balanced. The negative is on the outside, the positive is on the inside. So that is a nonpolar molecule.